Now that you have an understanding of currents in the ocean, surface currents, and a little bit about deep currents, I want to use that to explain an interesting weather phenomenon, one that should be particularly important this year. It's called, in America, El Nino. In the Pacific, they call it the Southern Oscillation. So depending on which part of the cycle you're in, it's either called El Nino or Southern Oscillation. A lot of times we abbreviate that Enso, E-N-S-O, El Nino and Southern Oscillation. I will usually just call it El Nino. Before we actually get to El Nino, though, I want you to understand the normal pattern of water in the Pacific. So here, with the side view, we have South America. So this is the American side of the Pacific. And we have Australia. We could also put Southeast Asia, similar pattern here. Now, we talked about in the equatorial regions that the winds are blowing from east to west. They're easterlies. And they're blowing back toward the equator. Now, if the wind is blowing from east to west and we have this nice strong trade wind, it drives a current on the surface. And that surface current is warm. So it's carrying the warmer water from off the coast of South America back toward Australia. But if the warm water gets blown and moves, water from underneath has to come back up and replace that. So that's part of our convection pattern. So this cool water is coming up to replace. So normally, in a regular year, the water off the coast of South America and even up into the United States off the coast of the Pacific is cold. Whereas off Australia, it's warmer. And we call this a thermocline. There's a shift between where the warm water is and where the cold water is. There's almost a distinct line. Now, you've probably felt something similar to the thermocline if you're swimming in a lake or in the ocean. You're swimming on the top and the top water is warm, but you get to a certain depth and it shifts to cold water. So we're talking about the same thing at a much larger scale. And ordinarily, the thermocline is shifted, so there's a lot of warm water off of the Australian coast and not much warm water off of the American coast. Again, that's because of the strong trade winds. Now, every 4 or 5 years, there's a cycle and these trade winds die down. Sometimes they even reverse. We don't have a good explanation for why that is. I could put out some theories, but long story short, we don't know. However, that causes a distinct change in the Pacific. And that distinct change is what we call El Nino. So if the wind quit blowing or quit blowing strongly, this thermocline would shift. And there would be less cold water here and more warm water here. So when we have an El Nino year, these winds are not as strong or they even reverse. You're going to get warm water off the South American coast and cooler water off of the Australian coast. Now I want you to see an image. So we're talking about El Nino and the Southern Oscillation. This image shows what we would call an El Nino year. The opposite of El Nino, the more normal condition, is called La Nina. So this literally means boy and girl, and there's kind of a neat history of how those names come about. You can look that up. But I want to focus on the difference. In kind of a normal year, a La Nina, the trade winds are blowing this way. So that carries the warm water this way, and the cool water comes up the field. So you'll notice this yellow region as opposed to that red region. This is cooler water off of the South American coast. That's the normal condition. But when those winds quit blowing as much and it shifts, you get an El Nino year. So now instead of having that cooler water, that cool tongue of water coming out, we have warm water all the way across. And notice, the water in the Pacific is now much colder. Now you may be wondering, why is this important? And that's because it has huge ramifications for the weather. So if we have warm water over here off the coast of the Pacific, there's more moisture absorbed into the air. The winds are shifted, they're not blowing strongly this way, and in fact they're sometimes reversed, so it's blowing this way. So it carries that warm, moist air over the Americas. And in an El Nino year, both Western South America and the southwestern United States tend to be abnormally rainy. That's hugely important this year. California's in a huge drought, and they're probably in for a lot more rain. Now that could be good in some respects. It could also be bad. because if you've had a drought and you don't have a lot of vegetation, you're almost a desert-like area, and you get lots of rain, that causes mudslides and floods and other kinds of damage. I want you to look up some articles. I think it's in one of your other assignments to read about this year's El Nino. It should be particularly strong. Read about some of the predictions that are being made, and then follow throughout the semester and see if they are backed up by what actually happens.